Hello and welcome to the Section 4.3 lecture today for Algebra 1 Part 2. I just want to go over some of these problems and kind of look at something that's a little bit special when it comes to geometric measurements. Today we're going to be looking at area and volume, not surface area and volume, but area and volume of what we consider to be composite figures. Okay, composite figures are just more or less irregular shapes built from regular shapes. So we're going to look at composite figures being kind of the two-dimensional figures, and then composite solids being the three-dimensional solids being built out of some of the regular solids that we deal with. So when we're finding area, a lot of times there's more than one way to do it. And it's up to you which method you prefer. When I look at this one, I kind of do think of two different ways. And one way is, I'm not going to say one way is easier than the other because I don't think they are. I think the big difference is just a little bit of how your brain views it. When I think of one method, I think of what we consider to be an additive method. And in the additive method, I'm thinking about breaking down the shape that I have into multiple more standard shapes. Okay. So when I'm looking at this one, and it may work, it may not. This one feels like I'm missing a little bit of information in order to do this the best way possible. In fact, I know that I am, so I can't really think of it in this additive sense. But I would find the area of each one of these sections. I'd find the area of section 1, section 2, and section 3. And then I would add those together. So the total area would equal the area of 1 plus the area of 2 plus the area of 3. Oops. That's not how I wrote the other ones. Now for this one, I am missing some information to be able to do that. I would need this width and this width. Since I don't really know those, I could make some speculation that might be right in the middle, and then, kind of break 30 up into a number, 8, and a number, where those two numbers are the same, those two widths are the same, but I am making a pretty big assumption there. In the long run, as we'll see in the second method, it doesn't really matter. But in order to really do that the right way, I don't really know how to do it the additive way. In the second method, so anytime that this first one doesn't work out, in the second method, it's another possibility to think about it as kind of the whole minus a part. Okay, so the way I'm thinking of this is I'm thinking that I have a big rectangle, and then I'm just taking a piece out of the middle, and that should be all I have to do. So let's go ahead and take a look at that one on this one, just to get a good idea of what I mean by that. So if I think of the whole rectangle, it's going to be a 30 by 15 rectangle. So I'm kind of thinking that the total area is the area of a 30 by 15 rectangle minus the area of this 10 by 8 rectangle. Now, since they're rectangles, those calculations are pretty easy. I do actually have 30 by 15 in the whole rectangle, which is 450. And in the small one, I do have 10 times 8, which is 80. So when I subtract 80, I get 370. And those are millimeters squared, because we're dealing with area. Okay? So we'll find the area of some of these composite figures right here. And yeah, should be okay. I think everything should work out. So sometimes in some of these missing, some of these composite figures, they don't give you a certain distance, but you can find one. Okay, like this one, I don't have this entire length right here, but I can find it because it comes from 7 and then this 6. So it's actually 13 feet. And that's a pretty good way to look at that. Now, I'm going to look at this one additively because we already thought about the subtractive method, the whole minus the part method. So you just have to break this up whichever way you'd like to. I suppose you could split it up vertically. Maybe I'll do that. All right, so I'm cutting it right here, and I'm going to look at section 1 and section 2 and find those two areas. Now for section 1, I don't actually know this part down here, but the same way I found the 13 on this side, I can find the length of this part as well. It's going to be this entire 13 minus the 8 that's coming this way. So that's actually 5 feet. I should have said that earlier, but I didn't. So this section 1 is 13 by 5, so area-wise, I'm thinking that it's equal to the area of a 13 by 5 rectangle plus area of section 2, which is an 8 by 6 rectangle. Okay, 13 times 5 is 65. 8 by 6 is 48. And so we'll get 113 as a total area. And those are square feet. Okay, for the next one, I have kind of a weird looking shape, but if I think about what makes it, it's going to be a rectangle and a semicircle, okay, or half a circle. So another important thing that we haven't seen in this problem is that I don't have a radius of my semicircle, but I can find it because it's going to have a diameter of 5. So its radius will be 2.5. Okay. So then figuring out some of the values that we need, it's going to be a 8 by 5 rectangle, and 8 times 5 is 40, plus half the area of this circle. So it's going to be half pi times the radius, 2.5 squared. Let's go and figure that part out. And divide it by 2 for 1/2. So that's the semicircle, this 9.8125. And then this rectangle is 40. So we have 49.8125. And those are centimeters squared. In this next one, it looks like, kind of like a pencil tip or something like that. You have to figure out what main shapes make it. And it looks like some kind of a rectangle and then a triangle on top. Some important things we need. We need the area of the rectangle. Well, that's 10 by 8, so that's 80. And then the area of the triangle is found by 1/2 base times height. The base is going to be 8, and the height is going to be 16. 16 all the way across minus 10. So the height is 6, and the base is 8. So 1/2 6 times 8 is 1/2 of 48, which is 24. So the area of this triangle is 24. If I add those two together, we get 104 inches squared. So notice I didn't really write any work there, but it wasn't too bad. If I really wanted to, I could say that it comes from 8 times 10 plus 1/2, 8 times 6. Okay? And that would get me the information that I need. Okay. The next one we have, again, looks like some kind of a rectangle, and in this case, this one happens to be a square. And then on top is a rectangle. A triangle. Missing some values on the triangle, but I do know this side is 12, but I actually need this side because 12 is going to be my base, but I also need my height. So let's talk about this as the height. Well, it's a right triangle, so I can use Pythagorean Theorem. And in Pythagorean Theorem, it would say that 13 squared is equal to 12 squared plus h squared. 13 squared is 169, 12 squared is 144, plus h squared. Subtract 144 on both sides. $169 minus 144 is 25. And in order to solve this, we have to take the square root of both sides. Square root of 25 is 5. Okay. So that makes this 5. And now we have everything we need. The area of this square at the bottom is 12 times 12, or 144, which I'm okay with putting easy formulas in the shape that you're finding the area of. And then the area of the triangle is going to be 1/2 6 times 5. I'm actually going to write that. 1/2 times 6 times 5. 6 times 5 is 30, and half of that is 15. So the area up here is 15. So the total area is going to be 144 times plus 15. And just to check that, we get 159, and those are meters squared. On the back side, we're taking a look at volume of composite solids. The basic volume formula that we've been using has been volume equals the area of the base times the height. So we're going to use some of the information that we found already and to finish these problems. Just to make it a little bit easier, I did use a lot of the same shapes. Okay. So like this one, this is the sort of pencil tip looking shape. And we found its area of that, as 104. Just to check, it is 8, it is 16, and it is 10. So the area of the base is 104. And the height is going to be the distance between the bases of 25. So to find the volume as area of the base times the height, it's going to be 104 times 25. It's going to be a pretty big number. 2,600. And those are going to be inches cubed. Because we're looking for how many 1 by 1 by 1 cubes will fit into that shape. For the next one, I kind of have this, the Tetris piece that we worked on earlier. We found its area to be 113. And just to check, we'll have 7, 8, 6, and 13. 7, 8, 6, and 13. So for this one, the area of the base, we're going to have 113. And our height, the distance between the two bases, is going to be 8. So my volume is going to be 113 times 8. And we get 904. And those are feet cubed. Okay, for the last two, we're going to take a quick look at the volume of a sphere. A sphere is a traditional ball type of shape. And it gives us the volume of a sphere as 4/3 pi r cubed. Okay, now this one we have diameter again. So we want to take a look at what the radius would be. That radius is going to be 9. Okay, so I have a radius of 9. Oh, clock's off. So a radius of 9. And so the volume is going to be 4/3 pi times 9 cubed. 9 cubed is 9 times 9 times 9. We want to multiply that by 4/3. My best way to do that is to put 4/3 in parentheses. And so we get 972. Is that right? Something about that doesn't feel right. Let's do the 4/3 first. Times 9, times 9, times 9. Yep, okay. And then we have to multiply it by pi. So we get 3052.08. And those are inches cubed. That was really just a practice problem to be able to do this problem that we had earlier. And this volume is going to be a little bit different. It's not just going to be the area of the base times the height. That can work for the cylinder part, the part at the bottom, but that won't work for the dome on top. So let's go steal our, we don't have that. I was going to say steal our area of the base of the bottom, but we don't have that. So we're kind of stuck doing this problem from the start. So for the volume of the cylinder, it's going to be area of the base, or we can use the Area of the base, pi r squared. The radius is 2.5. And then times the height of 8. So we get a volume of 157 in just this region. And then the volume of, I'm going to say half the sphere is going to be half of, I'm actually going to move this. Okay, I didn't want to move the 157 too, but that's okay. I already have that written there. So half of 4/3 pi times my 2.5 radius cubed. Let's get our 4/3 first. 2.5 cubed times pi. And then I do want to divide that by 2. We get a pretty ugly number, but we can go ahead and round it to 32.71. So my total volume now is going to be those two pieces added together. So 189.71. And those are going to be cubic centimeters. Okay, hopefully you got something out of today. Make sure that if you have any questions, they go over here on the left. Otherwise, I hope you have a great day, and we'll see you in class.